1 meter cube of air is heated reversibly at a constant pressure from 15 to 300 centigrade and then cooled reversibly at a constant volume back to the initial temperature. The initial pressure is 1.03 bar. Calculate the net heat flow and the overall change of entropy and sketch the process on a TS diagram. So we need to find the heat flow and overall net heat flow and the net change of entropy, and then we show it on a TS diagram also. Okay, so volume that is given 1 meter cube is reversibly at a constant pressure. So initially the process that is taken by the constant pressures, so the temperature T1 that is given 15 centigrade. If you convert that into Kelvin, just at 273, with it you will convert that into 288 Kelvin. Next temperature, the final temperature T2 that is given 300 centigrade. Convert that into Kelvin, you will get that is 573 Kelvin. The initial pressure that is given, that is 1.03 bar. Okay, if I draw it on a TS diagram, this process, there is two temperatures. One is the temperature T1 and the temperature T2. So at first, when the process follow from temperature T1 to T2 at a constant pressures, so it is obvious that this process is taken at a constant pressure. So the entropy initially is S1, this is 1. So the process reached to the temperature T2, and here you can say it is state point 2. So at state point 2 the entropy is S2. Now again the process is cooled down at a constant volume. So during constant volume the temperature will drop until it reach again to the initial value. It will write clearly. This is S2. So at a constant volume, this is a constant volume process. This is constant pressure process. Cooling at a constant volume will take place until its temperature reach again to the state point 1, that is T1. So here the entropy will be S3 and this state point 3. Because you can see that you can observe from this TS diagram the temperature at point 3 and at point 1 is the same, that is T1, and that is 288 Kelvin. I hope you understand its sketch on the TS diagram. Now we need to find the net heat transfer that is taken place. First, the heat that is taken place from the process 1 to 2, that is equal to mCp change in temperature. So we need to find the mass. So mass is equal to P1 V1 divided by RT1. So what is P1? That is 1.03. Volume is 1. What is R? That is constant 287. What is T1? That is 288. So after simplifications you will get its mass, that's 0.25 kg. Cp value is also constant. Now put this value in this heat transfer from process 1 to 2. So what is mass? That is 1.245. What is Cp value? That is 1.005, that is constant, and change in temperature, that is 573 minus 288. If you simplify that, you will get the heat that is supplied from process 1 to 2, that is 356 kilojoule. 356 kilojoule. Next is the heat that is supplied or rejected. We don't know whether it is supplied or rejected. If you don't know whether it is supplied or rejected, then you can easily okay, next we need to find the heat that is rejected from process 2 to 3, because cooling is taken place. So that is equal to mCV at a constant volume change in temperature. So what is mass? That is 1.245. What is CV? That is constant 0.718. Temperature change 288. On simplifications you will get that is minus 255 kilojoule. So this is the heat that is rejected from process 2 to 3. So the net heat in this process, that is equal to, and that is this shaded area, that this much. This is the net heat that is supplied during this process from 1 to 2, then 2 to 3. So just simply subtract this heat 2 to 3 from this heat 1 to 2. It is 356 minus 255, and you will get that is 101 kilojoule. This is the net heat that is supplied during this process. mCp ln higher temperature T2 divided by T1. Put the values, that is 1.24, that is the mass for 5, multiply by Cp, that is 1.005, multiply T2, that is 573 divided by 288. So upon simplification you will get the change in entropy S2 to S1, that is equal to 0.861 kilojoule per kilo. Next, the change in entropy we will to find from this process 2 to 3. So in that case, the change in entropy from process S2 to 3, that is S2 minus S3, that is equal to mCV, because it is at a constant volume process. That's why ln T2 divided by T3. So what is mass? That is 0.245. CV, that is 0.718, multiplied by ln, that is 573 divided by 288. On simplifications you will get change in entropy, that is equal to 0.615 kilojoule per kilo. Now this equation 1 and 2 we can now find the overall change in entropy. Now subtract equations 2 from 1. Now the change in entropy, that is equal to S3 minus S1, that is 0.245 6 kilojoule per Kelvin.